Tom. Hello, folks. Good morning, good afternoon, good evening from all around the world, from wherever you're joining us. I'm Alex, and I'm joined today by Tom, and you're here together with us at the Routing Loop. Um, how are you, Tom? How are
Yeah,
things?
I'm very good. I'm very good. Actually, I hope we're live. So I'm still looking at the Twitch screen to see if we're actually properly streaming. I see Dominic saying hi. Okay,
We
we're
are,
live.
we are.
I know it happened. It happened to Matt and Jamie before, where they started streaming. They spent like 15 minutes as if they're talking to the audience, and then they realized they haven't been streaming, and they had to start everything all over again. So I just
Yeah.
want to make sure that I think we're good. Dominic saying hi, so we're hopefully we're there.
Yes, we are. We are. I just refreshed my Twitch page that I have opened right next to us. So we are live. We're good. I see folks already here in the chat joining us. So I see Ken. I see Dominic. So hey, folks, thanks for joining us. Thanks for being with us every Thursday, 10:30 a.m. Pacific, 1:30 p.m. Eastern, um, talking about all things networking on AWS. That said, Tom, what do we have in store for today?
So we're going to go back to fundamentals today, specifically of application load balancer. I had a few customers in the last couple of weeks that were interested in some of the basics of how application load balancer works, specifically around the routing algorithm, so how you distribute traffic across different backends, and how do you do health checking. And there's some routing algorithms that also are able to use weights. So it's like a
Mhm.
halfway house between health checking and routing, where you can take some of the load
Nice.
away from a target that's misbehaving, but not misbehaving or not being as bad that it is completely shut down or
Mm.
considered unhealthy. So we'll just go
Got it.
through these different options, dig a little bit into how they operate, maybe a little bit of pros and cons. We can have a discussion. Alex, I know you've seen your customers use different load balancing algorithms on the ALB and make different decisions as well on how they configure the load balancer.
Yeah, and I think it's super interesting. Like this topic of the routing algorithms on ALB, um, is pretty prevalent when we're talking about different types of workloads. It's very different when you have, I don't know, EC2 instances, for example, behind an ALB, when you have pods in EKS, when you have, I don't know, some type of AI ML workload. So very different approaches to each. So I can't wait to talk about this today. Um, I know we recently launched automated target weights. Are we going to talk about that today as
We
well?
will. We will. Yes. So that's another one where I had a few customers ask me about it, and I thought it made sense. Just let's put together a set of slides, and we can talk about it on our Twitch channel and just have a discussion. I'm curious about the questions from the field. If people have questions, if they've seen those different algorithms, if they have used them, if they've run into any challenges.
Nice, nice, perfect. And I think, as you folks know, as always, we are looking forward to questions from you in the chat. We're ready to whiteboard. Tom has prepared some slides that would be able to help us go through the content. But your questions are the most important ones, so feel free to share them in chat. We'll bring them up. We'll talk about them in detail, and hopefully, this is going to be a super fun 1.5 hours, right?
Yeah, if we can fill 1.5 hours, it will be. I don't think we have that much content, but we'll see. Depends on your questions.
A lot of questions then. Let's do this. Um, so let me add you here to stage. I think we can see our slides,
Yeah.
and we're
Okay.
ready to roll.
Okay, so we're going to start with algorithms. And before we even start talking about how load balancer distributes traffic to the backends, we need to understand how we get traffic to the load balancer in the first place, because that is also effectively a way of distributing your load. And that is done through DNS resolution. So we'll start with an example here. We have an AWS region with a couple of availability zones. We'll have our VPC. Hopefully everybody knows what a VPC is. Inside, we'll have a couple of subnets, maybe some networking constructs like gateways and so on, maybe internet gateway to connect out to the internet. And then we deploy an application load balancer. When we do that, we have to select the subnets we want our ALB to live in. So say I selected those two, and then what will happen is ALB will deploy application load balancer nodes in those subnets. And you'll see elastic network interfaces appearing in those subnets representing each one of the nodes that the ALB is managing. So in my example here, I only have two nodes. They would have some private IP addresses allocated from the IP space of the VPC itself. And then if our application balancer is internal, then that's all there is. Our ALB, whenever you do a DNS lookup on the host name associated with it, would return these private IP addresses. I think for the use case today, I want to focus primarily on externally facing load balancers. So for that, we will need to make sure that we set up our load balancers internet facing. And then what will happen is we'll automatically assign, maybe not elastic, but public IP addresses to our ALB for each node that we're actually be hosting. So I'm showing you two nodes. As the load balancer scales in or out, there might be more nodes than one per availability zone. So that's one interesting thing about the ALB, that it doesn't really have a static IP address assigned to it. The IP addresses that ALB is using, both private as well as the public mappings, would be dynamic. So changing with the scaling. So to be able to get access to the ALB, we have to use a hostname. And
So one quick question here, Tom. As the ALB scales and you get more nodes in the VPC, in your subnets, you will consume more IP addresses, right? I think we have a best practice there of like those subnets within the ALB. There's some limitations. You have to have a number of IP addresses available in those subnets. So don't make them too small, otherwise your ALB is not going to be able to scale.
yeah, I think the minimum, I can't remember if it's a /27, I think we recommend to, which is, yeah, 32. It's either /27 or /28. We do recommend you have a certain amount of IP addresses in each subnet. In reality, the ALB can actually scale quite a lot. If you have a really large volume of traffic, the ALB scaling, it can take it all the way up to 100 nodes. So that means you're going to have to be able to accommodate those hundreds IP addresses in those extreme scenarios where you have a really high load. These are usually hyperscalers, so majority of customers probably don't have to worry about that. But you want to make sure that when you are setting your load balancers, you are giving them multiple AZs and then having say 30 IP addresses. I think we say recommend 8, but ideally you want to have more. You want to have a larger number of IP addresses if you're expecting scaling.
Yeah, at least 8 free in the subnet, but yes, make sure you plan for its scaling. And I think the other thing that's important is that as the nodes scale and you get more private IPs associated there with the ENIs, you also get more public IPs.
That is
So
correct.
they both scale.
Yep. So having ALB is not going to help you with limiting your utilization of public IP addresses, because as you scale, as new nodes get added, there will be more public IP addresses that you consume, public IPv4 addresses.
Yeah. I think I was so close to not asking about IPv6 in this section, but you took the conversation there.
I should have actually drawn it. Now thinking about it, I should have included V6 in there because ALB can be dual stack, and
exactly.
yeah, you can have V6 IP addresses here as well to accommodate your clients from V6. Yeah, I'm embarrassed. I haven't thought about including V6 now.
Tom.
Yeah.
Update is in place. And the other thing we launched recently, and just in case you missed it, I'm going to paste the link here. You can deploy your public IPv4 dual stack load balancer, application load balancer, without public v4 addresses. So it would only have v6 public addresses, and on IPv4, it would only have the private ones. That's a way in which you could use load balancers, public facing v6 only. Be careful because that means that you would not allow before clients on the internet to connect to your load balancer. So that's a decision that is really important, but it's supported.
Yeah, it's interesting
Now,
because I don't think I know of any networks that would be clients would be on V6 only. So what did you see on your end, Alex? Have you seen any customers go with that
yeah,
approach and do like a V6 ALB for the V6 clients and then maybe a
yes.
V4 ALB behind an NLB to limit the amount of V4 addresses on the V4 clients?
Oh, so let's start with the one that I didn't recommend, and I think it's pretty tough to sort of change the architecture to accommodate, which is putting an NLB in front of an ALB just to limit the number of IPv4 addresses. I think that's an architecture decision that requires one, a lot of changes, and two, consideration around cost running both ALBs and NLBs. Um, that's one thing, and I think Ken just added here the static IPs for ALB using Global Accelerator. Yes, that is one way to do that, and your ALB can actually be private, so you don't need public-facing ALBs with Global Accelerator.
Mm-hmm.
That's one. But to your previous point, or to option number one there, where you would have V6 only public ALBs. Yes, it is. The use case is pretty prevalent where customers they have their clients and their services on AWS, and they don't use private connectivity methods. They just use the internet gateway and egress on the internet gateway on V6. So think of an application and
Mm-hmm.
another application that needs to talk. They need to talk to each other, and the client is V6, the app is V6 with ALB, and traffic is controlled on both ends to be on V6.
Yeah, if you're
Really
controlling both
common use
ends,
case.
yeah, that makes sense. If you're controlling both ends, then you can do V6 only on both sides. But if at any point you're not in control of the remote end or your client, you've got to assume that it's going to have to be both V4 and V6, right?
Yeah,
Unless you know for sure they will only be V6, but I can't
true.
see that scenario being very realistic. Cool.
We got a question here from Dimitri. Um, dual stack CDN with ALB IPv6 only origin. Yes, that is another use case. We see customers using dual stack CDNs that support V6 only targets or origins, and those V6 only origins are the ALBs. Awesome example there,
Hmm.
Dimitri. Thank you.
Yeah, yeah. As long as
But let's go back.
you can hide the V6 ALB, then you're good.
Exactly,
Yep.
exactly.
So we going back to the DNS record. So this DNS record is something that AWS is managing for you automatically. So as those ALB nodes scale in and scale out, we would automatically add additional IP addresses into the list. All right. So for the sake of simplicity, I'm going to remove all of the additional constructs like VPC subnets. I'm going to hide the public IP address. Now you see the public IP address underneath each node, but just be aware that it's actually a private IP address mapped to a public IP address. But for the sake of the rest of the session, we'll just use this as an example with the ALB. We'll just look at the ALB, the AZs, and the nodes. So when a client does a DNS lookup on this ALB auto-generated hostname that AWS is managing, the client, if the load balancer is external, internet-facing, will get those two public IP addresses and then can decide which IP address to connect to. Now, as we scale the load balancer nodes out or in, we would automatically add those IP addresses into that AWS managed hostname. So I'm showing you two IP addresses, but yeah, again, we can have really large number of nodes, so all the way up to 100. And then every time you would do a DNS lookup as a client, we would return back a randomized list of 8 healthy load balancer nodes back to you. So you can then, as a client, decide which IP address or which node you effectively will land on after you've done DNS lookup.
Interesting question here, which I get a lot from a lot of customers. The DNS entries in the record, we don't control, or AWS Route 53 doesn't control the DNS caching times that the clients have, right? So is there a risk for a client to continue using an IP address, for example, even after the ALB actually scaled in and it's no longer using that IP address?
Yeah, it's a good question. So there's one time where there is a risk and there's a time where there isn't a risk. If the node
Okay.
completely fails, so say the node, I don't know, went down and it's unrecoverable, it's not able to handle traffic, and the client keeps trying to use the same IP address, ignoring like the additional lookups and just trying to hammer that IP address that it can't talk to, then it will not receive a response back. Like ideally, the client
Mhm.
would then shift over to all of the other IP addresses that were returned to the client through the DNS query. So hopefully the client can recover on its own by moving to another node. If the concern is about, say we had 50 nodes and then we scaled down to 40 nodes or 20 nodes or 10 nodes because we're no longer seeing the load that requires that many load balancer nodes, we will keep the existing nodes up and running for the duration of up to 7 days to allow for existing connections to drain. So if you have long-lasting connections, so that you expect to last for like weeks, application load balancer is not going to be your ideal solution. You want to look at like network load balancers that can handle long-lasting connections. But 7 days is a decent amount of time, and we will actually keep those nodes after we scale down to make sure that we have enough. We can allow for connections that are already in flight or users that are not obeying the TTL and trying to hit back on
Mhm.
a node that's no longer active. Those nodes will still be available. They would just be removed from DNS.
Got it. Got it. Okay. Do we have recommendations on how to set the TTL entries for those resource records in Route 53? I think we do.
I think that by default 60, I don't think you can change them. So
Mhm.
those auto-managed entries, so like the IP
Mhm.
addresses, the TTL for that auto-generated host name is 60 seconds. Uh, you wouldn't really use that name directly, right? It's not really friendly,
Exactly.
ALB123, and actually the ID is longer, the name is longer. It's usually a pretty long thing. So typically what you would do is if you're not using Route 53, you would set up some sort of a CNAME to this. So you have a custom name that your clients can actually use. Or if you're using Route 53, you'd set up an alias record. So you can, in Route 53, it's like you can think about an alias if you haven't looked into it. It's kind of like a better version of a CNAME where you can directly target an application load balancer because it's an AWS service. So you're not having to do the whole song and dance with resolving CNAMEs. And we also don't charge for resolving alias records.
There's a question here from Ken, and I think we need to absolutely clarify this. So, can you use the Lambda function to update the DNS records when the ALB is scaling up and down? You don't need to. It's done automatically.
Yeah. So
No
this
need
is
for you to do anything.
this is still purely application load balancer nodes. We haven't even gotten to your targets. So what's behind the application load balancer, your actual workload that you're managing as a customer. This is all about right now how AWS is managing the application load balancer for you. So this is more to give you an understanding that you don't really have to deal with any of this. If the load increases, we'll add more nodes on your behalf, and then we'll automatically update the host name that we have for the application load balancer so that if your clients are using that host name, they'll automatically see new IP addresses that they can connect to. And then when we're scaling down the ALB nodes, we'll automatically remove those IP addresses from the host name.
Perfect. Okay. Awesome.
Um,
So
cool.
the
Okay.
nodes, they're there. Now, what happens after?
Yeah. So let's talk about what's happening after the node. So now we talked about how do you get your traffic to the load balancer itself. Now we have the different algorithms that load balancer will use to send traffic to the target or your application that lives behind the load balancer. Right. So now we're expanding the drawing a little bit. We still have our ALB and the ALB nodes. I'm only going to show a single one in each AZ, but just be aware that they can scale out and in. And then we have a target group. Application load balancer supports a number of different targets. They could be EC2 instances, they could be containers, they could be Lambda functions. there could be just IP addresses that could be in the same VPC, or you can even target IP addresses back on premise. So you can have an ALB front ending your application in the cloud, and then the targets for that application could be either in AWS or on premise. Okay, so what's happening with the round robin load balancing algorithm? And there's really 3 load balancing algorithms that we're going to look at. Starting with round robin, then going to least outstanding request, and then the weighted random.
You have there on the bottom of your diagram cross AZ load balancing enabled. Do you want to talk maybe 2 seconds about what cross AZ load balancing is and how customers can use it or not use it?
Yeah. So cross-AZ load balancing is something you enable for a target group or for a load balancer, where you would define how do you want the load balancer nodes to load balance your traffic. So do you want the traffic to be load balanced from each AZ to all the other AZs? Or if traffic comes in AZ1, it should only load balance to targets in AZ1. So cross-zone load balancing enabled means you're using all of the targets in any AZ that you have available. So this I'll explain how it looks like from a kind of flow point of view. So first of all, let's talk about TCP connections. So the ALB nodes will set up a pool of TCP connections to the targets, but the ALB doesn't actually load balance TCP connections. Other load balancers that we have, like network load balancer, they load balance TCP connections. The ALB is load balancing requests. So it's ALB is purely for HTTP, HTTPS requests, and it load balances those requests across different targets, not TCP connections. So I've seen that being a big point of confusion with a lot of customers of like, oh, I'm going from a different port, or are the same users connecting, sending multiple requests? How is my load gonna get distributed? Just be aware that it's not TCP connections that the ALB is load balancing. These are HTTP requests. So client does the DNS lookup that we talked about earlier, right? The gets the list of nodes and decides to connect to the node up top, and it's sending its HTTP get. So what we're not covering here is all of the other features that ALB has, right? Like TLS termination, WAF, and like path-based routing. There's a set of things that you can configure here. We're purely focusing on just the load balancing piece. So HTTP connection gets in, maybe it's using TLS, maybe it's not, hits one of the load balancer nodes, and that load balancer nodes is going to do a round robin traffic distribution where this request might go to the first targets in its list. Another request to the same load balancer node will go to the next target, and so on. But you'll notice here that from an ALB node perspective, it considers all the targets in all of the availability zones as valid targets for its round robin algorithm. Right, so that node up top has a list of all the targets, and it keeps going round robin. Same thing would apply to the node at the bottom, and if you have additional nodes, each node has its individual view of all of the targets, and it's round robining across all of them.
One quick thing, because we are talking about the routing algorithm. One question that I get a lot is how does this tie to or into the sticky sessions piece? And is it like, should I use sticky sessions? Does the routing algorithm ensure that by default? Like how does that work? How did those two work together?
Yeah. So stickiness is where you have a requirement that you want to send the same client to the same target. Usually it means you're having some state on the targets. Right, so you're depending on the fact that if a client connects to a target, there's going to be some state on that target. So you want to make sure that if the client connects again, then they're landing on the target that has some awareness about you. In many web applications, the state would be kept outside of the kind of the web layer. But if you do have to have stickiness, we support cookies. So you can set up stickiness based on cookies to identify individual clients. And if you enable stickiness, instead of the round robin mechanism for sticky sessions, so if you know it's the same client, we will send that client to the same target that that client went to before. And then if it's a new client, then we're going back to the round robin mechanism.
Cool. Okay. And you have to have cross-zonal balancing enabled. So if
No.
you have sticky sessions, I think so.
Uh,
Yeah,
I need to check, but I'm not sure. Because, oh yeah, true. Because the stickiness is going to be, yeah. Otherwise, you'll end up with weird behaviors if the client decides to switch the node.
exactly.
Yeah.
Yeah.
One thing on the I wanted to add here is the cost. Because cross-zone load balancing, enabling and disabling it sometimes has cost considerations, but not in the case of application load balancer. So application load balancer, when you're enabling cross-zone load balancing, and like we're seeing here, a request comes in AZ1, but then gets forwarded to another AZ from the load balancer node up top, there is no cross-AZ charge for that traffic. So something
Not
to be
for the
aware of,
ALB.
not for the ALB. If it's NLB or if it's a gateway load balancer, so pretty much the two other load balancers, there will be a charge. If it's ALB, there is no charge for the traffic going across AZs. So once you hit the ALB and you're crossing AZs, there's no additional charge, but there will be additional latency associated with it, right? Because you're crossing the AZs, and the AZs should be, close enough that the latency is reasonable, but far enough away from one another that if there's a, massive disaster, both won't get affected. So usually we're estimating around 2 milliseconds, right? So if you are doing cross-zone load balancing, there would be additional latency associated with traffic crossing AZs.
There's one more question here from Karim Jamali. Are the TCP connections, the ones in blue on our diagram, pre-established and the HTTP request will leverage those existing TCP connections? Are those, I would add to that, are those TCP connections also used for health checks?
So if I remember correctly, I might have to double check that, but the for health checks, I think we're opening up new connections for every health check.
Mhm.
For actual data connections, there's persistent connections. So each node is managing its own pool of connections. So you're actually getting a lower utilization of TCP connections, right? If you had your clients connecting directly and each one opening up a TCP session, you have more TCP sessions landing on the targets. But if you're going through the ALB can effectively aggregate those TCP connections into a smaller number of connections, right? So you can reuse the same connection for multiple requests versus opening up individual connections for each request.
Yeah. And we have one more actually from DM Fiegel. Dimitri, what use cases have you seen for cross-zone disabled on ALB?
Yeah. So I haven't included anything on application recovery controller in the slide deck, but actually I think I have the next slide is cross-zone disabled. So we can use that as a baseline as an example. So with cross-zone load balancing disabled, each ALB node only will use targets in the respective availability zone. Right, so as connections come in, they only get load balanced between nodes in the same AZ. So ALB wouldn't cross zones. The benefits, there's a few advantages of that, right? We have that latency benefit. We're not crossing AZs. It's also a lot easier to control your application load balancer if you have any failure scenarios. So if it's a complete failure, it's the ALB disappears, everything disappears, it's fine. If it's gray failures where maybe it's an issue with your application, like you were staging your deployment and things in a certain AZ have an issue, or there's something on the AWS side that's a challenge, but it's a gray failure where you don't necessarily know exactly what's going on. If you have cross-zone load balancing disabled, you can decide to evacuate an availability zone completely by removing the ALB IP addresses from a particular zone from that DNS name we saw earlier. So you have a way to easier control zonality and allows you to create those more cell-based architectures where you can disable a particular AZ if you're seeing weird issues, and then investigate what's going on and then bring that AZ back up.
Yep.
Alex, you have
And I
anything to add? Anything you've seen?
No, I think this is great, and we released zonal shift. I think at reInvent last year.
Yeah.
So yeah, a lot of focus on the resiliency piece and the control that you get with zonal shift, part of application recovery controller. I pasted here in the chat the link for you folks to dive deeper into it, and maybe we actually do a session on how you can use it and dive deeper into it. I don't know if we've had one on the routing loop so far.
Yeah, I can't recall either. Yeah, I think that's probably a good
Mm,
topic to include.
cool.
Yeah,
Okay,
that
awesome.
there are downsides, I guess, as well, right? Because thing to be aware of is now imagine if you have we currently have a really nicely distributed set of targets. We have two
Yeah.
targets in one AZ, two targets in the other AZ. We're assuming they're the same size, same compute capabilities. So regardless of how our users are being split on the DNS side between AZ1 and AZ2, we are able to then kind of evenly distribute the load. If one of the AZs has more targets than the other, if in this scenario we would potentially have uneven load distribution, because DNS, let's assume in a really large volume of requests, DNS would be kind of 50-50. So we would spread our traffic 50-50 between top AZ and bottom AZ. But then if we have more targets in one of those AZs, it would be able to handle that load better than the other AZ. With cross-zone load balancing, let me just go back. It really, at that point, it doesn't matter, right? We can hit any node, and it doesn't matter how we distributed our targets across AZs, the distribution is going to be even.
Cool stuff. And I think there's a thing that we may want to clarify. I think we're going to get into that in the health checks piece. But so alias points to the load balancer itself, or do you have to control or remove one of those nodes? You don't have to control anything. Let's
No,
say that again.
there's a setting. You don't have to control anything. The host name that the load balancer receives when you create it, AWS takes care of controlling the nodes that exist in there. We will go into health checks and how we would actually influence the details in that DNS resolution side. And then we'll also talk about how it integrates with Route 53 and how we can use Route 53 to then do something once we know the load balancer is no longer healthy.
Yeah. Yeah. But just to clarify to your question, Kareem, alias points to the alias record that you configure in Route 53 for my app 123.example.com will point to the ALB FQDN. That ALB FQDN is fully managed by the ALB service. And the entries in that FQDN, the resource records, A and Quad A, are managed by ALB. You don't have to do anything. You don't have to run Lambda functions. You don't have to go in and edit those. However, as we go into health checks and as application recovery controller also helps with that, that's where you get control over what those entries in the FQDN resource records are. Hopefully that's clarified. Let us know if we answered the questions.
Yeah, I think that going into health checks in a second will also help with that.
Yep. There's, I think, one more question before we get into that. So would you suggest using zonal shift by default, even if you have cross AZ enabled to distribute traffic properly?
So you
No, I don't
can't,
think so.
yeah, you can't do zonal shift if you have cross-zone load balancing. It's either one or the other, because the idea with zonal shift is I want to remove. Can you see my mouse, by the way? I'm waving it right now.
Yep.
Okay.
It's actually getting bigger when you move it fast.
Yeah, I don't know why. Okay, perfect. So
Yes.
if say we do zonal shift, we will remove the top ALB node from our DNS, and then effectively we evacuated an availability zone. If there's like these targets would then talk to something else on the back end and so on, we chop off connectivity at the top. So clients are no longer using at the top AZ, and we now using the bottom AZ. And because we have cross-zone load balancing enabled, we never have traffic bouncing around the zones. It's once it goes in the zone in AZ2, it stays in there all the way to the end. So once you decide to do cross-zone load balancing disabled, you want to make sure that you're keeping zonal affinity all the way through your application stack. You're not crossing the zones anywhere, because as soon as you cross zones anywhere, you're removing the benefit of cross-zone load balancing. Right? Imagine there's a gray failure up top that, I don't know, something weird on the network where like 15% of packets disappear. There's a flapping link or multiple links. There's some issues. that you want to kind of get rid of. If you do arc zonal shift, you remove these AZ, problem goes away, you investigate, you talk to AWS, maybe it's on the AWS side, maybe it's something on your application, whatever that is, you're able to like cut off the zone. If at any point you have cross-zone load balancing enabled and you disabled it here, but then those EC2 instances talk to something else on the cross AZs, back in the potentially unhealthy AZ. So now it doesn't matter which AZ your clients come in on, they're all potentially affected by a single AZ failure.
Yep, exactly.
Alrighty, so that was round robin.
Awesome questions. Awesome questions. Before we head over, for all the new folks who've joined us, I've seen the count of viewers going up in the past few minutes. We are here today. I'm Alex, joined by Tom, and we are talking about application load balancing, routing algorithms, and health checks, and the fundamentals. We're diving deep into the fundamentals. This is the routing loop. We're here every Thursday, 10:30 a.m. Pacific, 1:30 p.m. Eastern. Thank you for joining us, and let us know your questions in the chat.
Yeah, we should add 6:30 p.m. GMT, I believe, UK time, 7:30, because I know there's a lot of folks joining from Europe. I think that might be better timing than we have in US, right? Because you're after work, you can come and join as well.
Grab a cuppa of something. I will be heading to New Zealand actually really soon, so I'm really excited about all these words that I've never known existed before, and I'm learning them. So I'll let you folks know what I learn when I'm back.
Yep. Okay. So we talked about round robin. We're moving on to another load balancing algorithm that the application load balancer can take, which is least outstanding requests. We will also go through two different scenarios, one where cross-AZ is enabled and one when cross-AZ is disabled. We're starting with the cross-zone load balancing enabled. Just like we saw earlier, the ALBs, each node would set up a bunch of TCP connections to the targets and manage those as a pool. Those are getting reused. When we had a question, they are getting reused. And then load balancers are load balancing requests, not TCP connections. Okay, so with least outstanding requests, we will be looking at the number of requests that each target has outstanding. So the requests that haven't had a proper response yet, and each ELB node can track it. And then that information is shared across the node. So we know across all AZs right now, because cross-zone load balancing is enabled, which nodes have outstanding requests, the largest amount of outstanding requests and the least outstanding requests. So you can see here from the list that the third node from the top in the bottom AZ, that has least outstanding requests. So when the customer or client connects to our load balancer, that's where the traffic will be distributed. And we'll keep doing that as long as the outstanding requests are the lowest, and then eventually another node is going to have less outstanding requests because it will be able to process others and start responding back. So that's how those requests are going to get distributed. Now,
outstanding means like in progress, kind of.
Yeah. So the ALB send a request to the node, but it never has seen the response yet.
Mm-hmm.
Right. So it hasn't. So it sends. So say it's as a HTTP GET for a particular path, then the ALB will forward that to one of the nodes, and it's waiting for the response, and the response hasn't arrived yet. We're increasing the counter of outstanding requests. And then when the response arrives, outstanding requests, we drop that counter.
Cool. What are some of the use cases that you're seeing with for using this particular routing algorithm?
Yeah, it's usually good for when your requests are not very uniform, so they can take different amounts of time to complete, or maybe your compute is varied, or the processing times are varied significantly. If the distribution of your request is pretty standard, then round robin or the other algorithm we're going to touch on in a second, the weighted random, probably a better fit. This least outstanding request works best if you have requests that you see consistently taking different amounts of time to process. We tend to
Okay.
recommend that if it's not as simple as just, okay, I'm going to go for this load balancing algorithm. Ideally, you want to try out all of them and then test your application and validate which one works best. Right? I've seen tests
Exactly.
done with, you can introduce some randomness and delays to some of the requests, and then you'll immediately see that the least outstanding request algorithm starts performing much better compared to round robin. But if your requests are pretty uniform, weighted random or round robin are going to be good for you.
Well, awesome. Okay.
Moving to cross-zone load balancing disabled. So like we discussed before, at that point, the AZ or IVIN, that's the AZ that you will be sent to the targets to. So if I'm a client, I connect the load up top. The least outstanding request algorithm is going to take into consideration only nodes in the same AZ. Right, so I will ignore the fact that at the bottom I have 2 outstanding requests on, again, the third node from the top. I will just look at the 5 and 3 and then select the 3 as my better target.
So important here is that not that two in the other AZ is going to be selected because it's in a different AZ. So even if it has less outstanding requests than what I have in the initial AZ where traffic landed from the client, it's still not going to be used.
Yeah, I think the best way to think about cross-zone load balancing disabled is that your view for any logic becomes zonal. Right, so I'm only going to consider things in my zone to make a routing decision. I'm only going to forward traffic to also things or targets in my zone. Everything becomes zonal, and nothing outside of your own availability zone is taken into consideration anymore.
Correct. And I think, yes, Karim, you got it right. So technically, cross AZ disabled is similar to having two LBs in the same VPC, one LB per AZ.
Mm-hmm.
Exactly.
Yep,
Yeah.
it's a good way to think about it.
There's a question here from Ken, and I admit I have no idea if we publish any metrics around the when we're using the least outstanding request LB algorithm. Are there any CloudWatch metrics related to this that we could see?
I actually can't recall if there is one. I'm not sure. I'll have to check too. I can't remember seeing one, so I don't know if we do.
Hmm.
But I'll have to check. I
I'll
can't remember off the top of my head.
got it. We'll check. We'll check, and we'll get back to you, Ken. Thank you for the question.
Okay. Final routing algorithm before we move on to health checks. Let me see, time check. Okay, we're good. Is
Mhm.
weighted random. So we're starting off again with cross-zone load balancing enabled. And this is very similar kind of at the surface to round robin, but the logic is rather than keeping a list of targets and going one after the other in an order, we're just picking them at random to send traffic to the destination. So as these HTTP requests comes in, the load balancer node will just randomly pick a bunch of targets. So that is just a random side of the load balancing piece. There's also this weighted bit here. So the weighted just means that under the hood, there's going to be some weights associated with the targets that can be automatically modified. So let's now say there's a scenario where we have multiple clients, there's multiple HTTP GET requests, so large number distributed across all of the load balancer nodes, and then they are randomly distributing them across all of the targets. So roughly what we should be seeing is around 25% per target, right? We have 4 targets, so 100% of the load more or less should be distributed evenly between all 4. And then with the weighted random, we also have this option that it's enabled automatically. There's anomaly detection. So we'll be looking at the targets and looking at the number of 500 responses, which are effectively errors that are being sent back to the load balancer. So let's imagine the node at the bottom is starting to have some issues. We don't know why, it just starts having issues and starts responding with 500 errors back to the load balancer. It's basically not able to handle the load, whatever's being asked of it. Uh, so first thing that's going to happen is we'll consider that node as anomalous. So we'll do anomaly detection, and it's based done every 5 seconds. It's comparison against all the other nodes in the same target group if it's cross AZ enabled. If it's cross AZ disabled, we will just do a comparison between nodes in the same availability zone. But because it's enabled, we're looking at all the nodes in the target group. We're seeing a lot of the errors, and then we're seeing that this particular instance is anomalous. Now, we can enable automation to automatically weight the traffic away from that instance that we've detected an anomaly on. That is an optional thing. So we can just get a notification, hey, we see a target that's anomalous, and we can take our own action. Or we can start using the weights, which AWS automatically takes care of, to start removing traffic away from the instance that's sending a lot of errors. And we initially, if that's enabled, would do it quite aggressively. So we would half the amount of traffic that's being sent to that target and then continue doing so as long as there's still an anomalous number of 500 errors. And this would go down to a very small amount. I'm showing 1% would be less than that, but we need to still be sending traffic to that instance to still be able to validate, are the anomalies still occurring, right? If we stop traffic to that instance completely, we wouldn't be able to validate if it's still behaving anomalously or normally. I want to differentiate here also from health checking. So this is assuming that somehow that instance is managing to respond with enough successful responses that health checking is still considering that instance as actually healthy. But for the actual customer traffic, there's so many errors that it does look anomalous compared to all the other instances. So we shouldn't confuse this with health checking. If that instance stops responding to health checks completely, so it returns 500 errors for health checks, then it will be removed completely. But this is just, it responds to health checks, but it's behaving weird. So we want to move some of that traffic, maybe give it some breathing room, maybe it got overloaded, whatever, and see if it will recover.
Got it. Okay, so we keep sending a small portion of the client traffic to those anomalous targets to figure out if the anomaly has stopped, essentially.
Correct. Yep, spot
Mm.
on. And then if we see, okay, the 500 errors are no longer anomalous, because there could be still 500 errors for everybody, right? Those instances could potentially be
Mhm.
returning 500 errors. And it's not about not returning any 500 errors. It's about that one target is sending significantly larger amount of 500 errors comparatively to other targets.
Do you
Okay, but
see
mhm.
do you see by the way, on this one, do you see that customers are using usually this in the not with actual client traffic, but maybe they have a different path on their endpoint, like a canary test that they use with the target group made out of the same targets that they have for their, I don't know, path app one or path app two and so on. And they sort of get that information from synthetic traffic rather than actually willingly getting client traffic to be dropped because of that anomalous because we still keep sending some traffic to that anomalous target.
Yeah, I think that the value here is because it has to be real customer traffic for there to be so many errors, right? And
Hmm.
the value is that even though you start having an instance that's starting to struggle, we can then remove really large number of traffic. It wouldn't even be 1%. I think it's a fraction of percent that's being sent, but there still needs to be some traffic going to it. Yeah, I don't know if you would be able to. It's an interesting idea to, like, at that point, if it's dropped to like below 1%, maybe we want to just be sending synthetic traffic to it and see if it's
Yeah.
healthy. I also wonder if at some point, once you get to that really low levels, your instance would probably just start showing up as unhealthy because it would be failing health checks responses, not just real
Mhm.
customer requests. But it could also be that you messed up your health checks and your health checks are very shallow. So they're
Yeah.
succeeding. but your actual request requires, I don't know, the instance to talk to some database that's in the critical path, and it's returning 500 errors.
You've mentioned there like the perfect keywords related to shallow health checks versus deep health checks. We're going to get into that today
Yep,
too,
yep,
right?
yep, yep. We'll touch on them in a second. We're just nearly done with the load balancing, and we'll jump into health checking.
Mm.
Okay,
One
just gonna
question.
add. Oh yeah, go on. Sorry.
Oh, for everyone who's in the chat, who's watching us, did you folks try this? I think it's again a recent launch this year, and we're curious to hear your feedback. If you've played with it, if you've tried it, if you're using it, how you're using it, let us know.
Cool. And then, so just to complete this example, once we detect that it's no longer anomalous, we start increasing the number of traffic to it, but the increase is linear, so like percent after percent, whereas the drop was, or we were basically halving the amount of traffic. So you can imagine this being similar to how TCP behaves. When it discovers an error, it just drops by half, and then it slowly ramps up. This is a similar behavior where if we discover an anomaly, we're dropping quite a lot of traffic away from that instance. And then if it's back to normal, we're gradually, gently increasing traffic back to the original level.
Nice.
Okay. For
Uh,
cross AZ disabled, sorry, is
one
a
more
question? Yeah, go on.
We got one more question. I have a lot of questions today. It says they're automatic target weights. I think I get this question quite often from customers around. Can customers control those weights?
No, not
Can
today.
I put my own weights? Yeah.
No, not today. You can do weights between target groups. So if you have two target groups, you
Mhm.
can control weights between those target groups, but you currently can't control weights between your targets. If that's something that you want to do, let us know. I think the service team is definitely looking for feedback and is interested in these kind of requests, because all the features that are getting developed, they're based around someone asking for it to be available.
Yep. So your feedback is super valuable. Your messages here in the chat get straight to our service team if folks are asking us for features. So let us know.
Cool. Just quick call out on the weighted random and automatic target weights. If you disable cross-zone load balancing, again, the view and the comparisons anomaly detection is AZ based. I believe you need at least 3 targets in that AZ to get any value. So unlikely that you will have less than 3 unless you have really big targets, but you just be aware that if you disable cross-zone load balancing, you'll need 3 targets plus to be able to actually be able to use the automatic target weights properly.
Yep.
All right. Final bit, let's talk about health checking. So I'll start with the basics and kind of how the health check setup looks like. We'll have our ALB node here with a private IP address and then the target instance. As we've seen before, ALB node, regardless if that ALB is internet facing or private, it will always have a private IP address inside of VPC. So the health checks coming from it will appear as if they're coming from a private IP address. And then when we're configuring the health checks, we can set up a number of parameters. So what protocol are we using, HTTP, HTTPS, and then we can specify a particular path, right? In my example, I'm using /health, but you can pick any path you want to test the health of the target. And then there's a set of different parameters that you might configure, like maybe the targets are listening on port 8080, whereas the application externally on the load balancer is using port 443 or port 80. So you can configure that health checking port. You can also set up a number of different thresholds. So how often you want to test, how many requests you need to succeed for healthy, or how many requests you need to see fail for unhealthy view, the timeout, and so on. So all of these things are configurable. What do you consider a success code? So I expect to see 200 back to consider the health check as healthy. And I'm sending requests at 5-second interval and have 2-second timeout. And as long as 2 succeed, I'm going to see the target is healthy. So now, how does the health check request look like? the path we've configured is going to be in the get, so the path will be hitting is /health. Now, another interesting thing, the host in the request, it's not going to be related to whatever application you're hosting. The host header will have the destination IP address of your target. Right, so our target instance in this scenario that with health checking is 10.0.0.15, and we'll be sending a host request to that specific IP address. And then if the port is custom, so not the original port that the ALB is listening on, we will also include a port in there. And then the user agent will identify itself as ELB health checker. And then if we get a 200 response twice, we will consider that target is healthy, and then we'll start sending traffic to it. The host header question, that is coming up for customers that host multiple applications on the same target instance, right? So maybe you have application 1, application 2, and you're hosting them on the same EC2 instance or the same target, and you want to be able to validate the health of those different applications separately, not just the health of an instance, but also the health of the different applications. So the way you would have to do it is differentiate those based on either ports or path, right? So maybe your path would be up 1, and then another test path would be up 2. You would have 2 different target groups pointing at the same instances to be able to validate 2 individual applications. Otherwise, the only thing you're testing is the health of the underlying instance. You don't exactly know if both of the applications, or however many you have on that instance, are all healthy.
There's a question here that we got from Fun by KK a while back, but we got to the place where we can actually answer it. So the question is, how exactly do LB health checks work? Are they something like telnet curl tests to the application port or something else?
Yep. So you can see here it's a regular HTTP or HTTPS request to a target. So it's a legitimate request that the ALB node is generating. If you have multiple ALB nodes, they'll all be doing their own health checking. So you'll see a lot of these requests coming in and hitting your instances.
Awesome.
Now, we did touch on this a little bit, the deepness of the health check, right? We have these 2 options. There's a deep check and a shallow check. I'm going to show you the deep one in a second. The shallow one is basically you're sending a request to validate if maybe the instance is up or just the application response on the basic level. But it doesn't really validate if all of the backend dependencies are working. So our recommendation typically is to set up deep health checks, but only for the backends that are in critical path, right? You don't want to fail a health check if, some external third party that really doesn't matter, I don't know, provides an image somewhere or like weather update fails and you fail a health check. But if it's a, customer database and without that you can't provide any service on your application, then you want to fail that health check. So from a health check point of view, now we have a whole load balancer service on the left-hand side. We have some kind of target. We're doing our get health. And then the instance would need to be configured that if someone hits the instance on the /health path, it will actually connect to all of these other backends. So either do some local checks, send a request to a database, or call an external API. Again, all of these should be on a critical path. Otherwise, you're just creating a potential risk. But if they respond healthy, then the instance returns 200, and application load balancer considers that target as healthy. And then if one of those is not available, again, say customer database, without it you can't offer a service, then you might as well just return unhealthy. And then we can talk about what happens once enough of these things become unhealthy.
Yeah. One thing before we go a bit further, Fun here is saying that it's a pain to understand if a target doesn't come up healthy, there's no visibility into why it's failing. I would highly recommend that you check and let us know if this works for you and if it actually answers your question. The reason codes. So whenever the ELB fails a health check, or the target fails a health check actually, and the ELB will return an API code as to why that health check has failed. There's a list of codes that we publish, and there's also a troubleshooting guide here. So this is the second link that I'm sharing. So fun by KK. Please let us know if this is helpful, and let us know if we're missing anything, and what would be making your life easier for troubleshooting this.
If you were to configure deep health checks, what you would need to do anyway on your application is configure all these dependencies, right? So every time your application is hit on a particular path that's used for health checking, you develop those dependencies to be checked versus if you do a shallow health check, it's just a request to your application. And then if that's failing, I would usually check on the instance itself, just directly log into it, do some TCP dumping, or like look at your logs and see what's going on if the request is actually going through, or if the service is even provisioned. Like if you have a healthy HTTP service and you're checking a generic, index.html path, you should be seeing successful health checks.
Awesome.
All right, so let's start failing things and seeing what is going to happen when enough of them fail. So we're back to our load balancers. We have multiple targets, 6 targets here. We have cross-zone load balancing enabled, and that will also, the cross-zone load balancing will also influence the behavior here quite heavily. So with cross-zone load balancing enabled, we're again using all of the targets in any availability zone. So regardless on which node you hit, you can get to any target. And initial state, everybody's healthy. We're running on deep health checks. Everything's working great. And then at the same time, here is a kind of deeper example of that original host name that we talked about and how it's being used inside Route 53 DNS. So we have our own host name called app.example.com that domain we host on Route 53. And then Route 53 has a number of different routing options related to how DNS is configured. In this example, we're setting up a failover record. So we have a primary record, which is the load balancer. So we've configured an alias. We could also configure a CNAME. We recommend an alias. It makes most sense. So we have an alias to that primary load balancer. We can see the 2 IP addresses representing the load balancer that AWS is automatically managing for you. If you remember, as ALB would scale in and scale out, we would keep adding and removing IP addresses from there. And then if that primary name fails, we want Route 53 to fail over and start returning some secondary host name. And my example here is going to be some static website on S3. Maybe something like, we're on the load, please give us time, whatever. So it's a static site that could be sent back to anybody trying to connect to in case our load balancer becomes completely unavailable. And we'll explain what that means. One other thing you need to enable within Route 53 for the failover to happen is evaluate target health. So this is not a proactive Route 53 health check, because Route 53 also has its own health checks where you can specify destinations, test it, and then use those in your configurations. This is something that you can enable for when Route 53 is pointing to an AWS service, like an application load balancer. So application load balancer is a managed service. So Route 53 can evaluate if that managed service is healthy or not. And then if it's completely unhealthy, then only then it would flip over to the failover secondary records to start returning the static website that's on S3.
And I think here is where the difference is. One of the reasons why we focus on the public facing ones. And as you folks know, for private resources, you have to define those health checks by yourself. So you would publish a CloudWatch metric based on those health checks, and then you would reference that in private hosted zones, in failover type records.
Yeah.
So
this
very
evaluate,
different.
yeah, this evaluate target health, it doesn't even require you to do any proactive health check. This is more of a signal that the service will get from application load balancer. I think that the advantage here is, so that's a benefit of using Route 53, because you can have these integrations. If you were to use here another DNS provider, which is, you can totally do that, and you would have to set up a CNAME. At that point, you would have to have your own logic to figure out your load balancer is unhealthy and you need to flip to something else. Like there wouldn't be this native integration between the managed service of ALB and Route 53. So if ALB, and we'll go through the examples in a second of when, in which scenarios we that evaluation of ALB comes in unhealthy and what will happen then. But that's a native integration between Route 53 and ALB.
Let's answer this before we head a bit further. So evaluate target health would take care of removing the LB node if its downstream targets are unhealthy. Not the evaluate target health. Think of it as two different layers. Think of it as I'm Route 53 and Tom is ALB service. Right? And Tom deals with ensuring that the ALB, the targets are healthy, your health checks are good, Tom deals with that ALB-123 DNS records. I only, because I'm Route 53 and I have enabled evaluate target health, I go ask Tom and I say, hey, Tom, is your ALB healthy, right? And Tom is telling me, yes, these are the entries that are healthy. So it's essentially the shared responsibility model, right, is still there. Route 53 doesn't go ahead and say, oh, Tom, you should remove these ALB nodes from your ALB. It is relying, though, on the information that ALB provides it that describes the health of those nodes.
Yep. I think it's going to come out in an example, because the question I would have here, like seeing this before going further, is what does it mean ALB is unhealthy, right?
Yes.
So I'm going to go over that, and then we'll explain at which point the ALB is considering things unhealthy and removing them from that DNS. Okay, so in this scenario, we're going to start failing things. Okay, so our DNS currently working, and let's start failing things. So first instance, when that goes down, nothing happens. Like if you have an auto-scaling group of your targets, that instance would then likely automatically be reprovisioned and added to the target group, and off you go. But let's say they're failing quite quickly. So now we lost 3 instances in the same AZ, but we're doing cross-zone load balancing. So from a perspective of ALB nodes in each AZ, like in the top AZ and at the bottom AZ, they still see 3 targets. So from a DNS point of view, we're still seeing both IP addresses, or however many IP addresses we have for ALB. They all seem looking good and still have healthy targets behind them, so we're keeping them in our DNS. And then finally, say all of the nodes went down, all 6, we have no healthy targets. What happens then? So at that point, application load balancer itself fails open. So there's no healthy targets. If I still see any requests coming towards me, I'm just going to try and send it to whatever targets I have. Maybe they're able to still respond. Maybe the unhealthy state is because they weren't able to respond to health check requests, and maybe something, some dependency on the backend failed, but we can still kind of handle things. So that fail open is kind of a last resort, last hurrah. If something comes in, I'll still forward it to the targets, even if they're truly unhealthy, that's nothing's going to happen. The traffic is going to fail.
So just to restate, because Enobag has the question, what does fail open mean? It's a safety mechanism that the application load balancer in this case implements to say, okay, if I don't see any healthy targets, which may happen for various reasons, maybe there are no healthy targets and I just terminated all my instances, right? Or I messed up my health check, right? And that's totally possible. Instead of checking for health 123, the path health 123, I'm checking for health. And obviously my health checks are all going to fail, but the instances are actually up and running and able to accept traffic. So it is a safety mechanism to ensure that your client traffic is not dropped, right? And it continues to be routed in case there's someone there that can actually answer to those connections.
Yeah. But at
You
the same
shouldn't get
time,
to this.
yeah.
Yeah.
At the same time, we also don't want to be using that application load balancer anymore, because the fail open is just a kind of an emergency. Let's try and send whatever I get, but also we don't want to be using that application load balancer anymore. So that's where this DNS comes in. So at this point, if the load balancer that has cross-zone load balancing enabled doesn't have any healthy targets, it fails open, and at the same time, the evaluation of its target health is negative. So that whole record would be considered as unhealthy. And if there's a backup record, in our example, we have a secondary backup record that will trigger only if the primary is unhealthy. If someone does a DNS lookup, they will not get the IP addresses of the ALB. They will get the IP address of my S3 static site and an image of, an update that we're, in construction or having issues. So those two things happen at the same time, simultaneously. There still could be clients that are misbehaving, that are not refreshing their DNS, or are kept the IP addresses static and trying to connect. It's probably less and less, or happening less and less often, but that's still a possibility, and that's where the fail open can help, right? If in case we now move the load away from our load balancer, we have a backup that we're sending to, and this is a static site, but it could be another load balancer in another region that could potentially handle the load. But if we have some stragglers still connecting to my old load balancer, maybe some of the nodes have recovered and they're able to handle the leftover traffic. So that fail open is kind of like a last resort mechanism to if someone still is trying to connect, we're going to try and send them to the destination. It probably will not work, but if it did, at least we were able to handle some traffic.
Yep, exactly. Anyone has any questions on this one? I know it's a bit, it's a lot of layers here that we're talking through. Does this make sense? Is it clear? Is it,
There's really two layers that you need to think about. There's a layer of what is the ALB going to do if all of the targets fail, and that is fail open. And if you're not using Route 53 for your DNS, that's it, right? You need to have another way to validate that it failed and update whatever DNS provider you have to go to a backup. If you are using Route 53 as your DNS, then together with the fail open on the ALB, we will also send a signal that the target health is down and the load balancer is not healthy, and that would trigger a failover in your Route 53 configuration if that's what you set up. So there's those two layers. There's the DNS layer, and then there's the load balancer behavior layer.
Quick question here, Tom. We have Karim making an observation there, but before we get to that one, if, for example, only my targets in AZ2 fail, and I don't have cross-zone load balancing,
I will have that example. I have that example on ahead of it. Yeah, I have that example. So we'll go over an example where we're failing things without cross-zone load balancing, and how does that impact DNS?
Nice. Okay, perfect. So before we get there, so targets down, default behavior is forward request.
Yep.
Evaluate route target would mean these LB would report all targets unhealthy, and Route 53 would remove the LB entry. Yes.
Correct. Now, there's something we need to do, because we may want to trigger these behaviors like fail open and DNS removal before we actually have every single target unhealthy and down. That's another very recently launched feature where you can set up target group thresholds for your health checks. So this is an example specifically for cross-zone load balancing enabled, which means that we will be evaluating things across all of the zones that we have enabled. In my example, I'm using US East, as you can see here, and I have 2 AZs. I have 6 targets across 2 zones, but we're looking at all 6. Doesn't matter what zones they're in. And what I've configured here is I want to trigger my DNS failover if there are less than 3 targets. I don't want to wait until the counter goes to 0 healthy targets and only then I'll do DNS failover. I want to, if it's below 3, so 2, 1 targets, whatever that is, I want to flip that DNS to a backup. And I also want to go into fail open sooner. I also want to go to the fail open at the same number. So if it's less than 3, I want to fail open.
Do you see, in this case, do you see if customers configuring these 2 percentages separately, like not equal, I would say, as in I want only if 2 do the DNS failover, and I want to fail open only if like 1 is still available or something like that?
I so far I've seen mostly the same. I think the only time I can think of using differently, because you can set up the the fail open has to be higher. So you can't
Mm-hmm.
fail open before you fail DNS. You have to fail DNS first,
Yeah.
and then you can fail open. If you're failing DNS, you probably want to fail open at the same time, and unless you want to. It probably depends
Mm-hmm.
on the number of target you have. If you have a really large number of targets, and you still have them there, maybe you don't want to fail open. You want to the remaining clients after you fail over DNS should maybe go to healthy targets. So you can have that
Mm-hmm.
number slightly higher, so you don't fail open straight away. You fail over DNS first, and then you fail open after a
Exactly.
certain amount of targets drops.
And that actually makes sense if you want to sort of drain those misbehaved clients that have DNS caching and they haven't flushed their DNS and so on. So you fail over DNS, all new clients go to the new target, and then um, you're slowly draining those existing connections that you have
Yep.
to your load balancer before you just fail open.
Yeah, it's more about that evaluation of how many strugglers do you think you're going to have once you
Mm-hmm.
flip DNS, and if it's the same number, you might as well have the same number. I'm showing you both, but you can actually, if you're keeping them the same, you can make the change in one place rather than going into two places and setting up the same number. Okay, so with this in mind, let's go through this example again and see what's going to happen. Right, so we have two targets go unhealthy. That's still fine. We have 4 targets healthy across both AZs, so that still fulfills our requirements of at least 3 being healthy. But then 2 more fail. So we're down to 2 healthy targets, which is below the threshold we've configured of 3. So at this point, that DNS failover and the fail open are going to happen simultaneously now. So we're failing open, we're sending traffic to all of the targets. If traffic comes in, and then at the same time, we're starting to fail over our DNS to the backup. If we don't want to fail open, we want to just send traffic to the healthy targets, we should increase the number of for routing flipping over to a higher number, maybe to 0 as well. Right, so maybe only we want to fail open when we have 0 targets, but we want to flip over DNS when we still have 3 or
Yep.
less than 3. Um, any questions here?
I think this is so good.
Okay. All right, let's talk about cross-zone load balancing disabled now. So we remember that creates like this logical zonal view where all the evaluations, all the logic is now happening per zone. So first of all, the TCP connections are per zone, the requests are being load balanced per zone. And so what happened with the health? So 1 target failing, nothing happens. 3 targets failing in the same AZ, we now lost an AZ, right? So if you were to connect to the ALB node at the bottom, there are no healthy targets that it knows about. So that AZ at this point will fail open, but just that AZ. The top AZ is still up and running normally. Bottom AZ went to fail open, and also it updated the DNS about its health. So now the IP addresses, I'm showing only one in the example, but imagine for ALB we'll have dozens in there. All of the IP addresses for that AZ are now getting removed from DNS. So if you do a DNS lookup on that domain, you will just get the 2030 IP address. You won't see the 198 IP address anymore because that is now considered unhealthy.
Well, there is a question which will require us to go back to the previous one. So very important. The flip over here, like where you have the target weights and sorry, not the target weights, the percentages for routing and DNS failover. If you can go to that previous diagram.
The one on weighted?
Yep,
Oh,
this
here?
just just a next.
Here?
This one. Yep. So here, if you don't have a secondary entry in there, and I think this is what you mean by this question, Kareem. If you have evaluate target health and you have a failover record, right? So the whole point of the failover record is to say, okay, I have a primary, but then I have also a secondary, right? If you don't have a secondary configured there, I wouldn't use a failover record because it doesn't make sense, right? I would just use a normal alias record, and if the ALB fails open, which is what happens if all the targets, I have less than 3 targets that are healthy, then I will continue to send traffic, and the ALB will continue to take traffic, and will continue to send it to the targets even if the targets are failed. So flip with the secondary only happens if you have a secondary. Very important.
So I would say the evaluate target health only makes sense if you can do something if that target health is evaluated as unhealthy. Right? If you have evaluate target health, but you're not using any routing logic in Route 53, and the evaluate target health is not just for failover records. It works for any other type of records that would evaluate health and decide if they're returning something based on the health of the backend. So if all you've configured is a single alias record, you can have evaluate target health. You'll just have, okay, it's unhealthy, but nothing you can do. You just have that load balancer, no backup.
Exactly. Awesome.
Cool.
Cool.
All right, let's talk about, okay, we talked about what happens if a whole AZ fails in the cross-zone load balancing. I'm assuming that makes sense because, right, the logic now is we're looking at things zonally, and if a zone doesn't have targets, we're moving that individual zone from DNS as well. If, again, all of the targets fail across all of the zones, that's where the whole ALB is considered unhealthy, and we're flipping back to whatever secondary record. Again, static website, but it could be another ALB, it could be another region, it could be something on premise, whatever you want it to be. Okay, and similar like before, we also have a way to change this behavior to specify when do we want to fail open or when do we want to fail DNS out. Now, again, because cross-zone load balancing is disabled, this evaluation is now done on a per AZ level. So the triggering for DNS failover and the fail open, we want them to trigger if there's less than 2 healthy targets per AZ. And then you can see at the bottom how the evaluation is done, where we're looking at each AZ. In each AZ, we have 3 targets. And then we're checking if there are at least 2 healthy targets per AZ to flip over DNS, flip over routing. If we want to flip over DNS before we do fail open on routing, again, we can change those numbers to update DNS before we drop all the targets. Okay, so example, what's going to happen here? Single target failing in one AZ, totally fine. 2 targets failing in one AZ. We're left in only 1 target that's healthy. That is below our threshold. So at this point, our DNS and the fail open are going to kick in. So the whole AZ is failing open. We're removing that entry from DNS, even though we still have a healthy target, because there's not enough healthy targets that would fulfill our healthy threshold requirements. And then if the same thing happens in the other AZ, we follow the same pattern. We now, looking at that AZ, we only have 1 healthy target below the limit of 2, failing the whole AZ, failing the health check, and then flipping over to our secondary record at that point.
Perfect. Makes sense.
Okay. This is all I had. I think we're just literally,
we are 5 perfectly minutes left. On time.
Yeah. Yes. If you want to play around with load balancing without even having to set anything up in your environment, we do have a public-facing load balancing demo where it goes into like the next level of depth for some additional topics like authentication or MTLS. So if you're interested in digging deeper into what load balancing can offer, yeah, have a play. It's kind of a fun front end to test out different features of load balancing.
Yep. Awesome stuff. Cool. I added here in the chat a few links for you folks, so make sure you grab them all from there. Tom, do you have our survey link by any chance? Close to you. I'll have to find.
Yeah, I got it. I got it. Let me get it. I'm gonna drop it in Twitch.
Perfect. So Everyone, let us know if you have questions, if you have topics that you want us to dive deeper into. There was a question in chat which we didn't get to, and I think we have 5 minutes to answer it really, really fast. So on a side note, for VPC Lattice, you need to manage load balancing. Is there a way to just get the ALB to be the target to have a single LB configuration for the app/service? So VPC Lattice, you don't need to manage load balancing in VPC Lattice. VPC Lattice is a layer 7 proxy with the whole set of application load balancing controls that you're accommodated with and used to from ALB. So there's no reason to use both VPC Lattice and an ALB as a target, except for when today you need to target ECS tasks, ECS or ECS Fargate. So VPC Lattice can target an ALB natively. You can use both if you really want to, but it's essentially putting a layer 7 load balancer in front of a layer 7 load balancer. So you would have to. I would question if you need that specific.
Yeah, you can replace, like I've seen customers replace the ALBs with Lattice, right? So
Yes.
that's the direction that you can take. I think where load balancing still makes sense is like on the front end. Lattice today doesn't have an external facing gateway, right? So if you want to get to Lattice, you have to come in through some kind of load balancer today, maybe network or application load balancer, hit your application, and then for your app to app, maybe microservices communicating, you can use Lattice for that.
Exactly. Okay, awesome. Awesome stuff. Well, we have 4 minutes. If anyone has more questions, let us know. If not, please fill in the survey. Let us know what you want to talk about. Next week, I'll be here again. I'll be joined by one of our most beloved product managers, Justin Davies. We're going to be talking about VPC Lattice more, but not just VPC Lattice. So stick around. It's going to be really fun. And looking forward to seeing you next week, folks. Join us Thursday, 10:30 a.m. Pacific, 1:30 p.m. Eastern, and 6:30 p.m. GMT, I think.
Yep, and then if you're not in UK, if you're the rest of Europe, it's GMT +1, I believe, right? It's going to be 7:30.
+2, +3, depending on how far off you are. Awesome. Well, thank you, Tom, for today. Thanks, everyone, for sticking around with us till the end, and looking forward to meeting you next week. Have a good one.
See you.